welcome dear students. We are on the CEC Gurukul lecture and we are in the series of electronic circuit. We are discussing the thermoelectric generator, in which we have discussed up to now that what are the thermoelectric generator and how they are classified on the basis of the material as well as the module, what type of material we can use for the construction of the thermoelectric generators. Now we discuss some of the application of the thermoelectric generator. Thermoelectric generator has a various application in the different field depending on the temperature range, power output and the heat source availability. The temperature range, power output and heat source availability will make it its application in the various field. So, some example of the thermoelectric generator applications are: first is the cooling device. First application is the cooling device. Thermoelectric generator can be used to cool electronic components like microprocessor, lasers, sensors, or by applying the electric current to create a temperature difference between the hot and the cold side of the module. So, this process is called the thermoelectric cooling or Pellet effect, and which is reverse of the Seebeck effect. Thermoelectric cooling devices have advantages over the conventional cooling methods such as compactness, its reliability, noiselessness and precise temperature control. By keeping in mind, we use the thermoelectric cooling devices. Next application is the power generator from the waste heat. Thermoelectric generator can be used to harvest waste heat from various sources like industrial processes like automobiles, power plants and even the human body heat that can convert into the useful electricity, and this can improve the energy efficiency and reduce the greenhouse gas emission of these sources. So, another application is the power generation from the waste heat. For example, thermoelectric generator can be integrated into the automotive exhaust system to recover some of the heat lost during the combustion and generate electricity for onboard electronic or the battery charging. So, that waste energy is used for the battery charging. Next, thermoelectric generator can also be attached to the human skin or the clothing to generate the electricity from the body heat for powering wearable devices or the medical implants. Sometimes it is used for the lighting or sometimes it is used for the medical purposes. So, the power generation from the next application is the power generation from the radioisotopes. So, thermoelectric generator can be used to power remote devices like sensor, wireless transmitter and in the spacecraft by using the radioisotopes like as a heat source. Now, you can see the efficiency that we can define by the power developed PL divided by the heat flow. Next is the I square ILQ and these are the various efficiency that we can use for the output. Radioisotopes are unstable isotopes that emit the radiation and decay into the other element. So, radiation can be converted into the heat by using a material that absorb it, means a heat absorbed by the material. The radiation can be converted into the heat by using a material that absorb it, such as lead or tungsten we can use as a material in this type of thermoelectric generator. The heat can then be converted into the electricity by using the thermoelectric modules that are attached in the in terms of the series and the parallel thermoelectrically. So, thermoelectric generators have advantages over the other power sources like batteries and the solar panels in terms of long lifetime, high reliability and independence from the environmental condition. Like solar cell can be damaged as because of the environmental condition, but these are thermoelectric radioisotope thermoelectric generators have the advantages over the power sources such as battery and the solar panels. RTGS radioisotope thermoelectric generators have been used to power many space missions like rover, like rogar, many rovers that can use this radioisotope thermoelectric generators. What are the challenges and the future direction for the thermoelectric generator? How we can change, how we can make it more efficient, how we can make its best use in the near future. So, what challenges we have for this thermoelectric generator? As a thermoelectric generator have many potential benefits for energy conversion and energy harvesting application, but they also face some challenges and limitations that need to be overcome or practically implementation. Some of these challenges are: number one is the low efficiency. As we require the high efficiency, so the challenge is the how we can get the high efficiency. So, efficiency of thermoelectric generator is limited by the Carnot efficiency, and the figure of merit of the thermoelectric material should be high, but sometimes it is limited. So, the current state of art thermoelectric materials have a figure of merit around 1 2 at a room temperature and 2 3 at high temperature. So, the resulting in an efficiency of 5 to 10% at the best we can get. To achieve the higher efficiency, new thermoelectric materials with a high figure of merit need to be discovered or designed by using the advanced technology, and such as the band structure engineering, nanostructuring, doping, alloying or heterostructure. If we change the structure, if we dope, then we can enhance the efficiency of the thermoelectric materials, and so that we can get the high figure of the merit. Next is the high cost. The cost of the thermoelectric generator is mainly determined by the cost of the thermoelectric materials and the modules that we use. So, current thermoelectric material are often composed of the toxic elements that are expensive and difficult to obtain. So, fabrication of the thermoelectric modules also requires the sophisticated processes and equipment that increase the cost. So, to reduce the cost of the thermoelectric generator, alternating material that are available in the abundant, and moreover they are cheap and they are more environmental friendly, we need to develop or discover. The fabrication of the thermoelectric modules also need to be simplified and scaled up to reduce the manufacturing cost and increase the production rate. Thermal management: the performance of thermoelectric generator depends on the temperature difference between the hot and cold side of the module. So, thermal management is the one of the challenge in the thermoelectric generator. So, it depends, it affects the performance of the thermoelectric generator. So, the difference between the temperature hot and cold in the module will affect the working of the thermoelectric generator. So, efficient heat transfer and dissipation are essential for achieving the high power output and the reliability and the efficiency will increase. So, the heat source and the heat sink need to be properly designed and matched with the thermoelectric module to ensure the optimal heat flow and the temperature distribution. Thermal contact resistance between the module and the heat source or the sink also need to be minimized to reduce the thermal losses. When we just maintained the minimum loss, then we can get the more efficiency by the through the thermoelectric generator. So, the thermoelectric materials and the modules also need to withstand high temperature and thermal stresses without degradation of or its failure. Next important point in the challenges is the system integration. So, thermoelectric generators are not standalone devices, but rather the component of a large system that includes the other elements also. That elements may be the heat exchanger, electrical converter, controller, sensor and the batteries. So, the integration of these elements into a coherent and the functional system requires the careful design and optimization of the various parameters like electrical impedance, voltage regulation, power conditioning, load matching and the system control. The system integration also need to consider the specific application requirements such as size, its weight, cost, durability, safety and the environmental impact. So, the future direction for the thermoelectric generator which we can have, that we use the what are the future direction, these were the challenges. Now, what are the future direction for the thermoelectric generator? So, first is the selection of the thermoelectric material. So, we choose the novel thermoelectric materials for the thermoelectric generator to increase its efficiency. So, the discovery or the design of the novel thermoelectric materials with a high figure of the merit is the key to improving the efficiency or the competitiveness of the thermoelectric generator. Novel thermoelectric materials can be obtained by using the advanced techniques like band structure engineering, like nanostructuring, like doping, alloying and the heterostructure to manipulate the electronic and the photonic properties of the material. That is also the extrinsic materials. Like another is the advanced thermoelectric modules. Material we will choose accordingly. Second is the thermoelectric modules, how can make it advanced. So, the development of the advanced thermoelectric modules with improved performance and reliability is another important aspect of the thermoelectric generator research and development in the future. So, advanced thermoelectric modules can be achieved by using the novel thermoelectric material with a high figure of the merit or by using the novel module architecture or the configuration that can increase the power output or reduce the thermal losses, in which we can make the less connections, the flow of current will be smooth, the device are connected properly. So, the novel module architecture is also required for the advanced thermoelectric module. So, advanced thermoelectric modules can also be achieved by using the novel fabrication method and techniques that can reduce the cost or increase the quality of the module. Another futuristic plan for the thermoelectric generator is the innovative thermoelectric system. So, in this the innovation of the thermoelectric system with the novel design and the novel material and the application is promising direction for the thermoelectric generator research and the development. Innovative thermoelectric system can be achieved by using the noble heat sources or sinks that can provide the high or stable temperature difference, or by using the noble integration schemes or strategies that can be optimize the system performance or the functionality. So, innovative thermoelectric system we can make by using the maintaining the source and sink arrangement, and we can take the material, we can integrate the schemes or strategies that can optimize the system performance and functionality. So, innovative thermoelectric system can also be achieved by exploring the new application domains or the scenario that can benefit from the advantages of the thermoelectric generator. So, thermoelectric generator are the device that can convert the heat energy into the electrical energy using the Seebeck effect. That is the main point in the thermoelectric generator. So, thermoelectric generator have the many advantages over the conventional power generation methods such as compactness, reliability, noiselessness and the direction conversion. Thermoelectric generator have the various applications in the different fields like cooling system, like power generation from the waste heat and the power generation from the radioisotopes. However, thermoelectric generator also face some challenges and limitations that need to overcome for the practical implementation, such as low efficiency, high cost, thermal management and the system integration. In the future direction for the thermoelectric generator, there is a require of the research and development which include the novel thermoelectric material. Second is the advanced thermoelectric modules and the innovative thermoelectric system. So, these 3 points for the future direction in the thermoelectric generator development. Number 1 is the novel thermoelectric material we require, that we can use by doping or by adding some material or by changing some material. And 3 material which we have discussed, first is the metal, second is the semiconductor and third is the complex material. So, these 3 as per the temperature dependent we can use these material, but still there is a requirement to enhance the property, enhance the efficiency of the thermoelectric generator. We can change the structure of the material, or we can dope, or we can take the nano material and another material to increase its efficiency. So, novel thermoelectric materials are required. Second is the advanced thermoelectric modules. In this case we can use the many thermoelectric modules attached one to one. Thermocouples can be attached one to one, but they are attached in a particular designing, particular architecture is required for that, so that it can give the output accordingly without the thermal losses, without the any losses in the electricity. And the next is the innovative thermoelectric system. In this innovative thermal electric system, we just have to maintain the interconnection with the other devices very in a proper manner, so that it can work in the better environment. Thermoelectric generator have a great potential for the energy conversion and harvesting application in the many sector and in the many scenario. So, this thermal can be used for the many devices, thermal electric generator in many devices as well as in the many. Thermoelectric modules work on the 2 different principles that we have defined earlier. One where the effect introduce the power of the module with a resultant cooling of the one side and the heating of the other side. This type of module have the low range and designed for the low temperature, while for the another is the Seebeck effect. So, these are up to now we have discussed the basics of the thermoelectric generator, how we can constructed, how they are used, how they are classified, and what are the main points and what are the advantages of these type of generator. So the type of generator are mainly classified into three parts, that is a fossil fuel generator, nuclear fuel generator, and a solar source generator. In the nuclear fuel, we use the wood, propane, jet fuels as the heat source. And commercial application, we have output range of 10 to 100 watt. Another kind of also we have another kind of generator that will define in the further lecture. Thank you very much.